This is the meter that we selected to do the harness testing and the strap testing. This is a digital multimeter and it's auto ranging, which is very important because it makes it very, very easy and simple to use it. You do not have to select any ranges, it does it for you. Here's the leads that come with the meter. The red one is a positive, the black one is a negative. And when you insert these leads, the black one goes right in the center where it says common. It's color coded, black to black. The red one goes over here on the right hand side, and it's red to red. When we check for resistance, which is what we're going to check on these straps, we will select the ohm range. That's the omega symbol. And there it is, and it's auto ranging. Right now it's on the mega ohm range because the leads aren't attached to anything. Before we start, we always short the leads together, and this way we do a really good test of the leads, whether they're making correct contact and the meter's reading correctly. And right there it's reading, it should read right around 0.2, a little less than an ohm, and that's 0.8, and that's a good test right there. And notice the omega does not have a K or an M in front of it, which means it's just simply 1/2 of an ohm right there, and that is a good test. When we're testing for resistance, the polarity does not matter. It doesn't make any difference with a digital multimeter. What we have here is a representation of current harness strap ends. This one here is an indigo. This is an original Skio. Of course it's broken. There's no buckle or wire or anything to it. It's broken right off. This is the Eternel straps, and this is what we come up with the replacement straps, which ultimately could replace all three. We're going to test this particular indigo strap just like we did all the other ones. We're going to test our leads, hold our leads together, and we're showing 2/10, 5/10, let it settle down, 6/10 of an ohm. And that is a good test that shows both the leads and the meter are testing correctly. Now we can go ahead and check the strap. This is the conductive rubber material here, and we gently place the leads on these areas like this, and we can see that this strap is about 2200 ohms. It's 2.3 of 1,000. So it's actually 2,500 ohms is what it's testing, which would actually be a good strap. Of course, there's no wire attached to it because we've removed it, but this would still be considered to be a good strap. Here's an original Skio strap. We're going to do the same thing. This whole thing is just plain rubber, and we're going to put the leads on it, and it is in the megohm range. That would be, well, bouncing all around, it's settling down, still in the megohm range. This is a very old and worn strap. 9/10, 8/10, 7/10 of a million ohms is what it's coming in. Meg means million. So we've really gotten our use out of this strap, and there's no need to pursue it any further with this. The next is, this is what your Ethernet straps look like when you first get it. They're very similar to this. It's got a little snap on the one side of it. And to test these, you would just simply go either right to the snap or right to the metal. It's all the same. It's all conductive. And then you go ahead and touch this material, which has a silver type conductive thread in it. And that's actually showing as a good strap. 1,400 ohms is 1.4K ohms, which would be considered to be a good strap. Unfortunately, they don't look like that for very long. In a very short period of time, this is what they look like. So we're going to go ahead and check this like we did. We're going to go right to the rivet, right to the snap, and we're going to touch the conductive material, which you can see that it is an open circuit. Megohm, and it is just simply an open circuit, as if a lead's not touching anything right here. So this is what most of your straps now look like. They are completely unserviceable, and they're ready to go in the trash. This is what we intend to replace all those straps with. We'll do a test on this one here, right to the rivet, right to the strap itself. Because this is a brand new strap, it's 4/10 of 1,000 ohms, which is 405 ohms approximately. Very representative of what a brand new strap should be. This is a direct replacement. It has the same snap. You simply unsnap the old one, snap the new one right in, and you are ready to go. What we're going to show you here is the difference between an old and a new strap. Now what I've got here is that the old strap will be the lower one and the new strap will be the upper one. You can see that the new strap has a nice shiny finish to it, where the lower, older strap has got a very dull, worn, abraded looking surface. It's worn out from oils, cleaning chemicals. Again, we're going back to ohms. There we are. We're on the ohm scale. Auto. Right now it says meg ohms because the leads are unattached. They're open. We're going to test. And it's down to point. There we go. 0.0, 0.1, 0.2. That's a good test. Now what we're going to do here is we're going to touch one of the leads. Doesn't matter which one. They're not. They don't care which way the polarity is. To the rivet. Then we're just going to lay the end of the probe on the rubber as if the rubber's lying against the skin like that, and that way we get a true reading of what's actually going on with the strap. 433. We're going to measure over here. It should go a little bit lower. 370. 260 something, and it should get lower and lower. We get progressively closer to the rivet because it's a a carbon impregnated conductive rubber strap. So as we get closer, the resistance will go down. And we're right next to it. And the resistance is down to 47 ohms. And of course, if we touch the rivet or the snap, the resistance is direct continuity. What we're going to do is go to the omega range, the resistance range. 1, 2, 3 clicks from the 12 o'clock position, and we're showing it we are in the auto range, and it's on the mega ohm because it is open. There's nothing, our leads aren't connected to anything. We're going to short the leads together and check both the meter and the leads. And there we are. We're in the ohm range, and 1.2, 0.3, that's a really good range. That means the leads are just fine. Now this is a worn out strap, and we're going to put one of the leads down here on the end, and then we're going to put the lead down on the other end and just lay it against as if it was laying against your skin. And you'll see that it again is in the mega ohm range while the kilo ohm range. And there we are, mainly there's the mega ohm range. Actually, it's an open. And open. Well, there was a little bit, there we go. We're in the mega ohm range. 2, 5, 1.7 mega ohm, 2 points. Anywhere in the mega ohm range is a badly worn harness. And again, it's open. This shows extremely high resistance and deterioration of the strap. Here we go, 1 2/10 of a mag. And so I'm pushing a lot of pressure on to try to get it to work. And let's see if it settles down, which it is not. 4/10, 5/10 of a meg, which is a $500,000. And you can see it's nothing like what a nice new strap would be, which is this one right here, which measures 379, 380 ohms. Oh, I didn't have it set on there correctly. There we go. 264 ohms. There's a decimal point. 260 ohms, and then we go over and do the same thing on this strap here, and you see the M, it's in the mega ohm range, and that's a bad strap. What we got here is a standard Eternal head harness. And we're going to test the the circuitry from the pins right here all the way out to the strips that actually touch the forehead. We're going to, same thing, we're going to test this. We're going to use an adapter with a tiny little female socket on the end of it because the pins are male that are inside the plug. We'll install this on one of the leads. Polarity doesn't make any difference. And we will short them together. And you'll see that it's 0.2, 0.3, 0.2 is a very good test. That's 0.1 of an ohm. That's a perfect test. So now that our meter and our little adapter have tested good, we are going to find the number 1 pin, which will correspond with, this is the number 1 strap all the way on the far left. So we are installed on the number 1 pin right there, and we will take the other lead and we will touch it to the number 1 strap, and you will see that while we have some continuity, and the whole harness is working. It is in the meg ohm range, and I will have to replace these straps here. It is time for them. They're older, they're used, they're worn out. But we know that we do have conductivity all the way from this plug, all the way through the wire and all the way up, and the other end of the wire is actually touching this strap. Now I'm going to go to the number 2 pin, which corresponds to the number 2 strap. And we do have continuity. Again, it's in the meg ohm range, it's high. I am going to replace these, but this is just to illustrate how you do this, how you test an entire harness all the way out to the little rubber strap. Same thing, number 3. Now these are all in order in a counterclockwise direction. This is an Eternal limb harness that we're going to test for continuity and electrical integrity. We're going to go ahead and do our little check again. Now we've got an extra adapter on the end of this, so we'll check this right to the end of it, and you can see it's 0.3, 0.5, 0.6 of an ohm, 5/10 of an ohm, and that's a very, very good check. We've got the harness all laid out without any straps connected to it. We're going to take our little adapter and plug it right into pin number 1 on the plug. There's only 4 pins in this one here because there are four limb harnesses or strap ends. So there is pin 1. And we're going to take our other lead and we're going to touch the red terminal, and you can see that is 4/10, 6/10 of an ohm. That is an excellent test that shows perfect continuity throughout that particular wire for that particular strap. Then we're going to go to number 2. Again, this is in a counterclockwise direction. And we're going to touch the next one. And you can see that we are reading almost straight continuity, which is excellent. That shows there's nothing wrong with that one. We're going to go to pin number 3. And we're going to go to the green terminal in here. And again, perfect continuity. And pin number 4. And again, it's perfect. Now, you can check them this way, or you can actually attach a strap to it and check it with the strap. Now, if you had a broken wire, which would represent the strap not being hooked up, where it works up to here, but you put it on the strap and you can see that there's nothing. It's in the meg ohm, it's an open circuit. So, while testing it with the strap attached, like that, with it on pin number 4 to the yellow lead, you can touch it and you can see that we have, let's see, let's let her settle down, 200, should be about, that's about 400 and some ohms, which is correct, all the way from the pin, all the way to the end of the strap, 400 and some ohms, and you see it's 0.423 K ohms, which is about 420 ohms. So there you go, and that's a real good test of the entire harness from the plug all the way out to the end of the strap. Now we're going to check the voltage output of the Eternal through the limb harnesses. To start, we're going to take a jumper cable, banana on one end, alligator clip on the other end, and we're going to plug into the back of the box to the black ground terminal, just like that. The other end, we're going to connect to our black lead. Then, on our meter, we're going to go to DC volts. On it, one click off of 12 on a DC volts right to there, and we will check the voltage output of each of these harnesses. We'll start with the red, it doesn't matter which one we start with, and you'll see the voltage symbol up top. Get put into it. And we're reading between generally 2 to 3 volts approximately. It'll bounce around because the because the signal output is varying depending on what program is being run. And that's the red harness. Now we'll go to the blue. The same thing, anywhere between 2 and 3 volts show that it's a good harness, a good output, and a good strap. Green, same thing, 2.4, 2.7 approximately, and yellow. And there it is, all 4 of them all have about approximately the same output, between 2 and 3 volts, and the head harness is checked in exactly the same way. Now I'd like to show you another facet of this multimeter. This can also check batteries. And we just go to the left, one click, and it goes to the 1.5 volt range. And we got a little load test area right here. I'm going to touch the leads to it. Notice that the red lead is positive. And we have 1.55459, and we have a green light, which indicates that this battery is a fully charged battery. Same thing with the AA. Again, 1.55 volts, and we have a green light. Now, if we have our leads connected incorrectly, you will see that it will not give you the light, but it will give you the negative sign on it, which shows that the leads are backwards. The multimeter still reads correctly, but you don't get your green light. Now, for the 9 volt, we have a 9 volt setting. Right there, and same thing, polarity wise, we touch them here, polarity wise we get a green light, and we get an 8.62, which indicates that it is still a good battery. If our polarity is wrong, we'll get a negative sign, but we still get a voltage reading because this is a digital multimeter. This indicates that these batteries are all good. Here's one other item you need to be aware of. When you're checking a battery and it is less than its rated voltage, I will show you that here's 9 volts, as if we're checking a 9 volt battery. But if this 9 volt battery was dead or only had a volt and a half, it would be like checking one of these other batteries. And you'll see you've got a red X, which indicates that it's definitely a bad battery. It's telling you the battery is definitely bad at only a volt and a half when it should have been reading 8.5 to 9 volts.